Unsupervised learning uncovers hidden structure in unlabeled data. It groups similar items, reduces dimensions for visualization, and detects anomalies without predefined answers. These techniques help explore datasets, generate hypotheses, and prepare features for models. Unsupervised learning discovers patterns in data when outcomes aren't labeled. Instead of predicting labels, it explores relationships, grouping similar items, extracting features, or revealing hidden themes. The central question is what organization or clusters exist within the data. These methods power 4 practical tasks: grouping customers by behavior to target marketing, spotting unusual activity in finance and cybersecurity, extracting common topics from large text collections, and compressing images while uncovering repeating patterns for analysis and storage. Unsupervised learning finds structure without labels. Clustering groups similar items like k-means or hierarchical methods to reveal segments. Dimensionality reduction compresses many variables into a few while preserving key patterns using techniques such as principal component analysis and TSNE. K-means groups data into k-clusters by assigning each point to its nearest centroid. First pick the number of clusters, then assign points to the closest centroid, recompute centroids as cluster centers, and repeat assignment and update until centroids stop changing. PCA transforms correlated features into new, uncorrelated axes called principal components. These components capture as much variation as possible in fewer dimensions, which makes it easier to visualize patterns and reduce noise while preserving the most important information. Supervised learning uses labeled data to predict outcomes, for example, regression for continuous values or classification for categories. Unsupervised learning uses unlabeled data to discover hidden structure, for example, clustering to group items or principal component analysis to reduce dimensions. Unsupervised learning brings 3 main challenges. There is no ground truth to judge models, so evaluation is subjective. Choosing the right number of clusters or components often requires heuristics or validation, and results can be hard to interpret without domain knowledge. Unsupervised learning uncovers hidden structure in unlabeled data. Common tools are clustering, which groups similar examples, and dimensionality reduction, which simplifies features for visualization and analysis. These methods are essential when exploring data to generate hypotheses and guide further modeling.